Okay, I will talk to Professor Kuntal Manna and then I will come back to you. Yeah, so recording has started. Good. And
Sir, when will be the quiz?
एक दो कुछ दिन में आपको पता चल जाएगा. We will let you know because today is my last lecture, so you will come to know soon. Okay.
Okay, sir. Thank you.
हाँ वो वीडियो अभी भी नहीं ऑन हो रहा है. नहीं ऑन हो रहा है ना. हाँ. अच्छा 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 ठीक है. आई विल ask. Yeah. Okay. Yeah, I will ask. Otherwise, okay. It's not happening. Okay. 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 Yeah. Okay. Okay. See you. Okay. Can you see the slides?
Yes, sir.
Okay. So let us go ahead and discuss this. I will again repeat this thing one more time. So this is the way we write rate of reaction. Okay, so it is shown it here. It is simple. We started with the simple mechanism that only one molecule of A gets adsorbed at the free surface, and then this A gives you product. And the way we write is, since surface is solid, so we take the fraction of the surface as its concentration, and that is 1 when it is totally vacant. Okay, and this is the initial concentration, and then this is the concentration at equilibrium, you can say. Again, please keep that thing in mind. We apply pre-equilibrium concept, so it means that we are talking about equilibrium between uh, A, S, and this complex. So A 1 minus theta and theta, and so we can apply, like K is equal to theta. This K is equal to theta, or Ka generally we write. Here we are taking affinity into A 1 minus theta. Okay, so K is this. From this we calculate the value of theta, and then we can write rate of reaction as you know mm, so this is how we calculate theta. Theta is Ka by 1 plus Ka. So please keep that thing in mind, that this will give theta is equal to Ka 1 plus Ka. This is also very important, that if a vacant site reacts with A, then theta is given by Ka into A plus K, 1 plus Ka. Okay, because in isotherm, what we look in the lab is how theta changes with, how rate of reaction changes with concentration of A, or how rate of reaction changes with pressure of A. If A is gas, then we use pressure of gas. So we know what is the theta, and then we can also know what is 1 minus theta. So 1 minus theta is simply 1 divided by 1 plus Ka. So these things are very important, keeping what is the form of theta and what is the form of 1 minus theta. Theta gives you the concentration of fraction of, you can say, fraction of occupied site, and 1 minus theta gives you fraction of unoccupied site. So this is quite simple. If you keep this in mind, then when we go and discuss about mechanism, it will be helpful. Okay. Now you see here that in this case, basically, if I plot theta versus A, initially it will be first order with respect to A, and then it will become zero order and that can be understood from this, because at low concentration of A, theta is equal to K into A, and at high concentration theta is 1, right? And that's why it is independent of concentration of A or independent of pressure of A. Then we discuss the second case, that suppose a dye molecule, for example hydrogen gas, gets adsorbed, and then there is dissociation. In that case, what happens? Okay, and then we discuss all these things. It is not very difficult. It is simply A2 1 at the initial, at equilibrium this will be A2, and since two of the sides are going to get used, so I write 1 minus 2 theta, and then this is written as 2 theta. Sometime we can write theta dash, but keep this thing in mind that this is theta dash means this 2 theta is theta dash, so 1 minus 2 theta will be 1 minus theta dash. So sometime please keep that thing in mind. So where 2 theta or theta dash is the fraction of surface occupied. Okay, and then 2 theta, this thing is giving you product. This A2 molecules dissociates to give atoms. Okay, and then I can apply equilibrium concept here, and then I can write Ka into K is here rate constant. So Ka into A2 concentration 1 minus 2 theta square, since 2 of the sides are being used, and then K minus A 2 theta square, because here 2 sides has been occupied, and so I can get K, and from that I can know 2 theta by 1 minus 2 theta, and then I can get theta, and theta will be, so 2 theta square by 1 minus 2 theta square is K A2 to 2 theta by, so 1 by K half. Okay, so 2 theta by 1 minus 2 theta is K half, A2 half. And if I do inverse of this, then I get 1 minus 2 theta by 2 theta, 1 by 2 theta minus 1. And that gives you 1 by theta, 2 theta, or 1 by theta dash, you can say. And theta dash is this thing. Again, you need to keep this thing in mind, that what is the form of theta dash when it is getting dissociated. Please keep that thing in mind, that here fraction comes into picture. So
सर
whenever you, yeah, please go ahead.
here k है वो k is ka by ka minus, right?
Yeah, K is the way we write K by K minus A. Okay, this is,
इक्विलिब्रियम वाला k भी बोल
ये
सकते हैं
इक्विलिब्रियम वाला K है, प्री इक्विलिब्रियम कंसेप्ट लगा रहे हैं हम, और ये रेट कांस्टेंट है. इज इट ओके?
yes sir
यही होता है ना, रेट कांस्टेंट फॉर फॉरवर्ड रिएक्शन डिवाइडेड बाय रेट कांस्टेंट ऑफ रिवर्स रिएक्शन.
ये तो
Okay.
इक्विलिब्रियम का हो गया k
हाँ,
इक्विलिब्रियम
प्री इक्विलिब्रियम लगा रहे हैं. आई एम टेलिंग यू दैट प्री इक्विलिब्रियम कंसेप्ट आई कैन ओनली अप्लाई when first step is fast and second step is slow. Then I can only write this thing. Right? This we have already discussed. Again, here generally in case of adsorption, first step is fast. It is a reversible step. In fact, most of the reversible reactions are very fast. Yes, and then the second step is slow. Okay, so please keep that thing in mind, and we are applying pre-equilibrium concept. Okay, is this okay?
सर मैं क्लास के एंड में इस रिलेटेड डाउट पूछूंगा, लाइक अभी थोड़ा लंबा हो जाएगा.
Okay, so this is 1 by theta dash is this, theta dash is this, and then we have already told what is the rate of reaction. Rate of reaction is simply K into 2 theta square, because 2 of the A comes out and gives you product. So rate of reaction is K into 2 theta square, or K into theta dash square. So you can do this of square. Okay, so the next things which I discussed is, if suppose there is a reaction between A and B on a solid surface. In that case, what will happen? So till now we are discussing about one reactant. Now there are two reactants. So a simple case is that A gets a job, B gets a job, and then rate of reaction is simply, then this adsorbed A reacts with adsorbed B to give you product. If adsorbed A reacts with absorbed B, then you can simply write K into theta A into theta B. This is the rate of reaction. So again, you can write like this: A initially A naught, 1, B, B naught, and then 1. Okay. So at equilibrium, what you'll get is A, 1 minus theta A. This is theta A. Theta A is fraction of A occupied. And here theta B, fraction of fraction of surface occupied by B, that is theta B. And so what will the bare surface? Bare surface is 1 minus theta A, because some of the sides are occupied by A and some of the sides are occupied by B. In that case, we write this. And please keep this thing in mind. Here, all the sides which we are talking about, I uh, can be, means A doesn't have, it's a special side. So AB has common sides, which means the sides which takes A can also take B. But there can be case where A and B has different sides. In that case, we will not write 1 minus theta A minus theta B. I will discuss that case also. But if sides are same for adsorption of A and B, then we will simply write 1 minus theta A minus theta B, because that is the vacant site. And once we write that, we can calculate. Again, we can write Ka. K is given by theta A, 1 minus theta A minus theta B into A. You can see here that it is theta A 1 minus theta A minus theta B A. So Ka can be written like this. Similarly, Kb can be written like this. So Ka into A is theta A by 1 minus theta A minus theta B. Kb into B is theta B by 1 minus theta A minus theta B. And if we add these two, we will get theta A plus theta B, 1 minus theta A minus theta B. If I add 1, then I will get 1 by 1 minus theta A minus theta B. So basically, now I know 1 by theta A minus theta B. Okay, and that is basically this quantity. So theta A will be Ka into A into 1 minus theta A and theta B, and that I have already calculated in terms of this. So I can write simply theta A is equal to Ka into A by 1 plus Ka A Kbb. So there are two of the reactants. You can think similarly, if there is a 3 reactant, then what will happen? Then you will have simply theta A is Ka into A, 1 plus Ka Kbb plus क्या होगा? मान लो C है एक और react Kc into C. So that is quite simple. So please keep that thing in mind. In which all A, B, C is, A, B, C is, all of them is basically competing for the same site. Okay, so theta A we calculated, theta B we calculated. So rate of reaction is equal to K into theta A into theta B. And this I have already discussed. So I just wanted to repeat so that you keep means you have, again you will think that how to derive these equations. Any question here? कुछ है तुम लोग के पास क्वेश्चन जो कि तुम लोग पूछना चाहते? अभिजीत, yes.
So in the last case which you show where we have to use 2 reactants basically.
Okay.
So if there are 3 reactants, then the rate of the reaction will be K into theta A into theta B into theta C, right?
It depends. That here what I am saying, A, B, C is adsorbing, then you will get this thing. And then if suppose C is, I will discuss one case of that. For example, if C is an inhibitor, am I right? In that case, only AB is reacting. I is inhibitor is not reacting. Am I right? To give the product. So it depends that what are the things which is involved in the reaction in the final step. So it will also depend on that. If all three are involved, then you are right. That theta A, theta B, theta C. Again, all this should be in the bound state. If it is free, then it will not be the case. I will discuss that case also. Okay, is it clear, Abhijit?
Yes, sir.
Okay, any other questions?
Sir, theta and theta B are different because of the different size of A and B probably.
A and B, and also because they will adsorb differently. Any two molecule will adsorb to a given site differently. So K and Kb is different. If K is equal to Kb, then you can write theta A is equal to theta B.
And theta is the total fraction of the sites on the substrate occupied by A, right?
So theta is, so for example, take a solid surface. There is suppose 10 sites, am I right? And 2 of them are occupied. Then theta is 2 by 10. Okay.
Okay. Okay.
So when it is, suppose there is no gas adsorb, then what will happen? There are 10 sites and all 10 sites are bare. So fraction of sites which are bare is what? 10 by 10, am I right?
Yes,
सारा
sir.
sites bare hai, am I right? It is not occupied. So fraction of sites occupied will be 10 by 10 is equal to 1. Okay. And now so that is 1 minus theta, which you can say. Here theta is 0, so it is 1. So suppose 2 sites are occupied, then theta will be 2 by 10, which is 1 by 5. And the fraction of site which is unoccupied is what? You can say, Abhijit, what will be the number? अगर मान लो 2 sites occupied है, 8 sites are vacant, then what will the fraction of vacant site?
So 1 by 4, 2 by 8.
So 1 by 4.
Yes, I'm
8
by 8.
8 by
8 by
10
10.
ना, 8 by
8
10.
by
4 by 5 होगा ना? 8 sites are vacant.
Yes.
Out of 10.
Oh, okay. I did not listen to the question carefully.
Yeah.
Sorry.
It's okay. So this is the way you calculate the fraction. Is it okay?
Yes, sir.
Anyone who have other questions?
Sir, theta A can be equal to theta B, na? Means there can be some sites where both A and B can be adsorbed.
So Himanshi, if Ka is same, Ka and Kb is same, then theta A and theta B will be same.
Okay.
Okay, equilibrium constant should be similar, same. Then only
Okay.
that can happen. So जिसका ज़्यादा Ka होगा, affinity ज़्यादा होगा, that will occupy more. Isn't it?
Okay, sir. Yes, sir.
Okay, so that is the case, and then now let's go to next item. So this is, yeah. So I will discuss few more cases and then I will go to mechanism. How to get the mechanism. ठीक है. अब देखो इसमें क्या है, when so same case which I discussed in the last slide, that when adsorb A and B reacts, so what we'll do, A, B, this is K, Kb, and then we are writing rate of reaction is equal to K into theta A into theta B, and this is K into Ka Pa by 1 plus Ka Pa K plus Kb Pb. Theta B क्या होगा, Kb Pb divided by 1 plus Ka Pa plus KBPB. So that's how you get the rate of reaction. So now let us think about different cases. For example, so rate of reaction, this total thing which we got in the last slide. So suppose I have there are several different cases can happen. This is the general case which we are talking about. A sparsely covered surface. What does that mean? A and B are very weakly adsorbed. So in that case, this Ka, Pa, Kb, Pb can be neglected in comparison to 1. So 1 square is 1, then you are simply K, Kb into A into B. So simply concentration se the variation will be simply, rate will be simply proportional to concentration of A, proportional to concentration of B. Okay. Suppose one of the reactants is strongly adsorbed, for example, A strongly adsorbed, then one can be neglected, this can be neglected, and then you have this kind of equation KB A into B by K square PA square. Concentration of A square, you can write concentration of A square. Yeah, so I think what I have written. Yeah, so PA PB था तो यहाँ पे PA PB होगा. So please, अगर you know, if it is gas, then you will PA PB. Okay. So ये भी PA PB कर लो, because we are discussing gas. This will be PA PB. It doesn't matter. If it is liquid, then you will write concentration of A, concentration of B. So what happened that PA, 1 PA cancels out. So rate of reaction is proportional to PB, but inversely proportional to P. Okay, so please keep that thing in mind, that if one of the reactants is strongly absorbed, then you have this kind of case. So several different kind of things you can think of, and that is one of this. So although we are getting this kind of rate of reaction, expression for rate of reaction, but then there are several different equation can come up when you take different kind of cases. Now let us see what happens when adsorb A reacts with free B. So what I am talking about is A is getting adsorbed, B is getting adsorbed, but this adsorb A and B is not reacting. What is happening? Adsorb A reacts with free B. Am I right? In that case, what I will write? Rate of reaction. This is adsorbed A. So this is theta A into pressure of B. So I will not write rate of reaction is equal to K into theta A into theta B. What I will write? Theta A into PB. In that case, you see there is no square term at the denominator. So just by looking at the rate of reaction, you can tell whether adsorb A is reacting with adsorb B or adsorb A is reacting with free B. So that's why it is very important to understand, that what is the, theta, what is the term for theta, what is the term for 1 minus theta. These things are very important. Okay, so rate of reaction will change. Now, if suppose A is strongly adsorbed, then what will happen? This 1 and KB PB will be negligible. PA cancels out. So rate of reaction doesn't even depend on pressure of A. It only depends on, because PA cancels out, it only depends on pressure of B. Is it clear? यहाँ समझ में आ रहा है? Because these things are very important. यहाँ पे क्या हो रहा है? This A is not reacting with adsorb A is not reacting with adsorb B. Adsorb A is reacting with free B. And so I will not write rate of reaction is equal to K into theta A into theta B. What I will write? K into theta A into PB. And that's how you get this term. A similar case I discussed when A is strongly absorbed. In that case, rate of reaction will not depend on the concentration of A or pressure of A. Okay, and now the next question, case which you can think of, adsorption of two gases without mutual displacement. What does that mean? A and B has different site. Okay, A and B has different site. Okay, and so if A has absorbed, B has adsorbed on their side, what I am going to write concentration of bare surfaces 1 minus theta A. Not 1 minus theta A minus theta B. Please keep that thing in mind. Because A is not competing with B. They have different site. So suppose A के लिए 8 site है and B के लिए 4 site है. Am I right? And 4 of A is adsorbed. 4 sides of A is adsorbed. Then I will write simply vacant site is 4 by 8, not 12 by 8. So suppose A has 8 vacant site and B has 6 vacant sites, suppose, and four sides of A is occupied, then vacant site will be 4 by 8. And also concentration of vacant site and concentration of occupied site of A is 4 by 8, not 4 by 14. राइट, पहला केस जो हमने डिस्कस किया था ए बी के लिए टोटल था 14 साइड. अगर ये एग्जांपल ले तो सारे साइड्स ए और बी के लिए है. A can also come on all of 14 sites, B can also come and occupy all the 14 sites. But here B cannot occupy this site for A and A cannot occupy site of B. And that's what we say adsorption of two cases without mutual displacement. Because site is different, so B will not come and displace A. And similarly, A will not come and displace B. So in that case, what I will write for this 1 minus theta A. And ये हमने already किया हुआ है, that is simply K PA by 1 plus K PA. You see, there is no term KB PB in this. Because, B is not competing with A. And same thing is for theta B. Is this okay? Is it clear?
Yes, sir.
Yes, sir.
Okay, so these are few of, yes. Any question?
So, are we saying that the two surfaces are different? I mean, S1,
नहीं,
S2.
एक ही surface है, इसमें हाँ 2 sides हो सकते हैं. Surface can have 2 sides.
Okay.
Two different kind of. एक साइड पे A adsorb करेगा, दूसरे साइड पे B adsorb करेगा. Okay? Is it clear?
Yes.
Okay. Yeah. So मैंने already I have discussed when A and B can occupy any of the sides on the surface, then what will be the case? Okay. So once you know that, the last thing which I am going to discuss is inhibitor. Okay. So that's what I told that the second substrate can be inhibitor, and in that case, what I will get, A and I both are adsorbing for the same site. I का different site नहीं है. Please keep that thing in mind. And so theta A will be 1 plus Ka PA plus Ki PA or Ka PA. Only thing is now it is A going to product. So I is not taking part in the last step. Only it is inhibiting. कैसे inhibit कर रहा है? By occupying the sites, जो free sites हैं surface पे उसको occupy कर दिया. So now A has less number of sites where it can go and sit. And this A is, giving you product. So rate of reaction is K into theta. And theta is this. Now you don't have to write. You know that all the sites are getting occupied by either A and I. And so what will be the equation? So once you start writing these kind of things, you are going to have a feel of what kind of theta A will be, what can be the expression of. Isn't it? बताओ.
Yes, sir.
Okay.
सर एक मतलब इंट्यूटिव डाउट, जैसे कि जब हम रेट ऑफ रिएक्शन लिखते हैं तो जनरली हम कॉन्सेंट्रेशंस इनटू रेट कांस्टेंट लिखते हैं, और यहाँ पर हम थीटा लिखते हैं जो एक फ्रैक्शन है. तो लाइक डेवलप कैसे किया होगा इन्होंने, लाइक थॉट कैसे आया होगा इनके दिमाग में?
कि वही है, इसको ऐसे ही किया जाता है कि हाउ मेनी साइड्स व्हेन यू आर टॉकिंग अबाउट सॉलिड, उसका साइड्स क्या है, कितने साइड्स हैं. ओके, सो 10 साइड्स हैं. इट इज so 10 sites, you see, it is very difficult to calculate. So whatever site it can have, site 5 site, एक में बताना, it is very difficult कि how many sites for reactant. And that's why people start using fraction.
So because very efficient
sites है उसको एक मान लिया हमने. Right? So 10 sites है तो fraction तो 1 ही होगा ना, because there are 10 sites and all 10 are vacant. So concentration as such, you can think of concentration of vacant site is 1. So that is 1.
तो किसी लैब में अगर आपके ऐसे कोई सबस्ट्रेट है तो फिर आप कैसे देखते हो कि ये कितना % एब्जॉर्ब कर पा रहा है?
Yeah, there is a way to look at that. हाँ, उसको बाद में तुम देखोगे. I think when Professor Kuntal will tell you how to look at this value of theta. Okay. तो उसको आप देख सकते हो. It is not that difficult to know. Okay. So there are instruments for that. So ये theta A, when you know theta A, and then you can know how it is related to the pressure or concentration of A and I. But please keep this thing in mind. Why I am writing like this? Because A is absorbing at same site where I absorbs, or I is absorbing at same site where A absorbs. दोनों का different site होगा, then तब वो inhibitor होगा ही नहीं. Am I right? Because then theta A will be simply KPA1 plus KPA. तो ये तो occupy ही नहीं कर रहा है, इसका अपना site है. Then it will not act as inhibitor. How it is acting as inhibitor? Because it is the sites which are present for A, some of them are occupied by this inhibitor, and that's how it is acting as inhibitor. Okay. Okay, and now if suppose same, we also talked about reaction between A and B. Okay, and suppose I put inhibitor, what will happen? You have three things. So this is theta A. Theta B इसी तरह तुम लिख सकते हो. But rate of reaction क्या होगा? Because adsorbed A is reacting with adsorbed B, so it is K theta A into theta B. I terms doesn't come. That's what I discussed few minutes ago. But what will happen if there are three species which are getting adsorbed? So in that case, the one which is involved in product formation is here. Am I right? And the third is basically acting as inhibitor because it is occupying the sites which should be occupied by A and B. All right. So this is the way we can write, all these equations. ठीक है? Now let us go. अभी तक हमने क्या किया था कि what we have done is we know the mechanism and then we derive what can be the expression. Now let us think about if rate of reaction I know, experimentally I can measure. Then what will the mechanism? Okay, so think about this. So this is combination of hydrogen atom at surface. Okay, this is one of the things which people try to get the mechanism, looking at how theta changes with, or how rate of reaction changes with pressure. Okay, so what they found out that first order, it is a first order process, and second order at high temperature. Okay, second order at high temperature. So it is under first order under certain condition and second order at high temperature. So what you can write is constant h square by constant plus h, that we have already discussed. Am I right? तभी हो सकता है कि when h we neglect, then it will be second order, and when constant neglected, then it is first order. Now, how I can get this whole process, whole thing? Okay. अब देखो H और H react कर रहा है to give it H2. So what can be the things which you can think of? One is either adsorbed H reacts with adsorbed, another adsorbed H. दूसरा क्या हो सकता है? Adsorbed H reacts with free H. Am I right? यही दो हो सकता है ना?
Yes, sir.
Yes.
Am I right? Okay. So if adsorbed H reacts with adsorbed H, what kind of expression you should get? Theta H into theta H. If adsorbed H reacts with free H, what rate of reaction you will get? Theta H into H, certainly multiplied by the rate constant. Now you know what is the theta H. Theta H क्या होगा? This is the value KHH into 1 plus KHH. And अगर थीटा एच से मल्टीप्लाई करोगे तो इसका क्या होगा? स्क्वायर. एंड इफ थीटा एच इंटू एच करोगे तो क्या हो जाएगा? इसमें एच मल्टीप्लाई कर दो, एच स्क्वायर बाई 1 plus kh into h. So tell me what should be the mechanism?
Sir,
Adsorb H reacts with free H.
Good. इसमें क्या होता है? इसका स्क्वायर है, right? So either it will be order 2 or 0 order. It can't be first order, isn't it? सोचो, और कोई हो सकता है? Any mechanism which is possible? Isn't it quite simple to know that it must be at one adsorbed H must be reacting with another with a free H? Not like this, one adsorbed reacting with another adsorbed. अगर ऐसा होता तो what we will get in certain condition first order, sorry, 0 order, and in other condition it should be second order, like this, not like this.
समझ नहीं है लास्ट में क्या होगा.
Okay, so मैंने ये बोला कि suppose adsorbed H reacts with adsorbed H to give you S2. In that case, you will get a square term, am I right?
Yes.
Okay, मान लो 1 neglect करोगे तो क्या हो जाएगा order?
Okay, yes.
0. And मान लो KH H neglect करोगे तो क्या होगा order?
Second.
Second. 0 order तो तुम्हें मिल नहीं रहा experimentally.
Yes.
You just rule out this. What about this? This is same as this one.
Yes.
All that means is adsorbed H is reacting with free H. Am I right?
Yes.
Yes.
Yeah. So I hope now you understand how to get the mechanism in case of heterogeneous. Now let's discuss the second case. Hydrogenation of ethylene at copper surface. Okay. At copper surface. So this is the reaction C2H4S2 copper C2S6, and this is the rate of reaction which was found to be. Okay. Now tell me, what are the different things possible here? A and B का reaction है. So what are the different things possible? Theta A into theta B, theta A into B, theta B into A. These are the three things possible. That adsorb A reacts with adsorb B, adsorb A reacts with free B, and adsorb B reacts with free A. Am I right? Only three possibility?
Yes, sir.
Yes.
Okay. Now tell me square term किस में आएगा?
Sir, theta A into theta B.
Only इसमें तो आएगा नहीं. Am I right? What is theta A? क्या होगा बता दो तुम लोग. क्या होगा थीटा ए? के ए ए ए C2H4 को मान रहा हूं मैं. ओके, 1 प्लस के ए पी ए प्लस ये होगा ना. सिमिलरली थीटा बी. तो जहां पर भी थीटा बी लिखोगे, थीटा बी इज ऑल्सो के ए सॉरी के बी पी बी डिवाइडेड बाई 1 प्लस के ए पी ए प्लस के बी पी बी. इसको अगर मल्टीप्लाई करोगे दोनों को तभी ये स्क्वायर टर्म आएगा. बी से मल्टीप्लाई और पीबी से मल्टीप्लाई करोगे तो स्क्वायर टर्म नहीं आएगा, और पीए से भी मल्टीप्लाई करोगे इसको तो स्क्वायर टर्म नहीं आएगा. तो स्क्वायर टर्म यहीं पे आएगा. एंड देन वी आर नॉट सीइंग के इनटू S2 टर्म. सो व्हाट डज दैट मीन?
ये एक बहुत स्लो होगा.
S2 is weakly adsorbed.
So C2H4 is strongly.
Not as strongly I cannot say because one
Oh, okay.
negligible नहीं है. तो इसका अर्थ है only thing what I can say कि H2 is weakly adsorbed. I cannot also take out this one. Strongly बोलोगे तो it means that you have to also neglect this 1 plus. So simple way to say that H2 is weakly adsorbed. Is this okay?
Yes.
Does this make sense?
Yes, sir.
Okay, so this is very important mechanism. देखो तुमने कितने दो mechanism we have already discussed. It's not very difficult. Once you know कैसा होता है, बस you can. Now let us go another one.
Sir, please explain again why didn't we neglect one?
One मैंने कहा कि it depends on how strongly C2H4 is adsorbed. I can simply say C2H4 is moderately absorbed. What does that mean? I cannot neglect one. Okay? अगर बहुत strongly होता तो क्या होता? One को भी neglect करना पड़ता.
Okay, sir.
Is it clear?
Yes, sir.
Okay. So next question, C2H4 H2. निकेल पे C2H6 दे रहा है. Okay. This is the rate of reaction. Now again we can think of 3 different cases. And now you tell me what should be the क्या होना चाहिए? Theta A into theta B, theta A into B, and theta B into A. What should
Theta
be?
A into B.
हाँ, A क्या है इसमें?
C2H4.
C2H4.
Is it clear or not? It is quite simple. Square term तो है ही नहीं, तो theta A into theta B तो चला गया. Am I right? और जो यहाँ पे नहीं है, तो वो that must be free one which is reacting. So S2 is basically B here, so theta A into B. So not very difficult. Now let us see one more. Now यहाँ पे पहले हमने association of S2 किया था. अब let's look at dissociation of S2 at hot tungsten surface. And rate of reaction is proportional to S2 half. Okay, S2 half पे है. So what can be the thing that you have to look at? So एक चीज हो सकता है कि जो absorbed है, that is getting dissociated. Okay. Then one thing can be that 1 minus theta S2 means vacant surface can give you, ये ज़्यादा possibility नहीं है, so you can just take it out. And then the second is vacant surface reacts with free S2 to give you. So vacant surface basically activates without absorbing this S2 to get it dissociated. Okay, get it dissociated. And now
H2 won't attach to vacant surface.
Yes, so H2 doesn't attach to vacant surface. What does this vacant surface does? It catalyzes this H2 to without absorbing. Just presence of this makes this H2 to get dissociated. Okay. Now these are the 3 things which is possible. So you can write all these 3 things. And you know how to write this. Theta S2 is K half S2 half 1 plus K half S2 half. And then 1 minus theta S2 is this. So 1 minus theta S2 I just wrote to write this one. So this is S2 divided by 1 plus K half S2 half. Okay, S2 divided by 1 plus K half S2 half. Okay. Now these two both has the possibility that both can be right or wrong. Am I right? Because this can also give S2 half when I neglect K half S2 half. Okay. And then there is also possibility that this can also be true, because if I neglect 1, then K half S2 half, and S2 divided by this will also give you S2 half. So both can be the possibility. Okay, both can be the possibility. Now tell me how I can differentiate between these two if experimentally, if I was told to do that.
So, like if K into H, K half into H half is like considerably bigger than 1, then that would be independent of like the
What can you
theta H2 वाला जो केस है उसमें like अगर K into H2 वाले टर्म में much greater than 1 होगा तो फिर जो ओवरऑल टर्म है वो तो 1 ही बन जाएगा ना रेट ऑफ रिएक्शन
या
तो कांस्टेंट रहेगा मतलब इट वोंट.
Okay, so there is one thing which you can think of. You see, if suppose S2 is, if I take S2 in excess amount, what will happen? In first case, what will happen in the second case?
In first case, it would be independent of H2.
And the second case?
Half order dependence.
Half order. Okay. So in first case, it will be independent of S2 concentration, because if at higher S2 value, am I right? At higher S2 value, what you will get, or higher K value, both things are possible. Higher K value or higher S2 value, what will happen? That 1 can be neglected and S2 half cancels out. This will be 0 order. And then this is S2 1 plus K half S2 half. And if K is higher or S2 is higher, then in that case 1 cancels out, and then this is power half. So these two mechanisms can be differentiated. Now let us think about, you can play with the S2, pressure of S2, or you can play with the temperature. So if suppose it is endothermic process and I have taken hot tungsten surface, so what will happen? K will increase or decrease?
Sir, it will increase.
Endothermic, K will increase. Am I right? With the temperature? होगा या नहीं होगा? Just tell me.
Sir, it should increase with increase in temperature.
Temperature. Okay, that's good. So one thing you know that. Now tell me hydrogen dissociation. Okay, because it hydrogen dissociation. Is it endothermic process or exothermic process?
Sir, endothermic process, because energy.
Endothermic hoga because you have to supply energy.
Yes.
So at hot tungsten surface, what do you expect? K to be?
So K should increase then.
K value should be high. Am I right?
Yes.
अगर K value half होगा तो यहाँ पे क्या होगा? K high होगा तो?
So 1 should be neglected.
Yes. And then order should be?
0.
यहाँ पे क्या होगा order?
Half.
So which is the mechanism? This should be the mechanism. First one or third, second one? This one or this one?
The second one.
ये समझ में आया? दो चीज है, दोनों में हमने बताया कि in under what condition, you know, one should be order half and another will be order 0. इससे इस दोनों में differentiate कर सकते हैं, am I right? And we know that S2 dissociation is endothermic. For any bond, if you are breaking, then you have to supply energy. And so if you increase the temperature, K will increase. And in that case, one can be neglected in both this, and then this becomes 0, this becomes half. It means this is the mechanism. So sometimes just by looking at this thing, you will think, okay, this is order is half, and so this may be the mechanism. This is not true. So here you see, which is quite unusual, that vacant site is somehow catalyzing S2 to its atom or to dissociate. Is this okay? Is it clear?
Yes, sir.
Okay, so last case I will discuss, and then tutorial में भेज दूंगा, आप try करना. So same thing, K NS3 and D2 iron NS2D, it is giving NS2D, then V is equal to क्या होगा? This is the rate of reaction which has been given. And now अब बताओ, D2 half है, 1 plus K NS3 square है. क्या क्या चीज होगा? Can you tell me? Again, theta NS3 is reacting with theta D2, means adsorb NS3 reacting with adsorb D2, adsorb NS3 reacting with D2, and adsorb free D2 and adsorb D2 reacting with NS3. कौन सा होगा? It's quite simple. यहाँ पे होना चाहिए. Am I right? That this is right. But D2 half कैसे आएगा? D2 का डिसोसिएशन हो रहा होगा. Am I right? तभी हाफ आएगा फ्रैक्शन.
Yes, sir. Yes.
So this is D2 association with यहाँ पे dissociation होगा, and this 1D will attach to basically you should write 1D is attaching to NS3. So you can write yourself, try out this. But this is the way you can simply know the mechanism just by looking at this. अगर केवल D2 होता तो we know that there is no dissociation of D2, but अगर D2 half है, so I know that there must be dissociation of D2, and then 1D must be reacting with NS3 to give you NS2D. So this is the mechanism of the reaction between NS3 and D2 at iron surface to give you NS2D. Okay, so this is the way you can know the mechanism of heterogeneous reaction. It is not very difficult if you understand the kinetics, how this rate of reaction changes with the mechanism. And we have done enough practice to know how this mechanism changes with the mechanism changes the rate of reaction. And just looking at rate of reaction, we can derive the mechanism. Okay. So if what I can tell you that if you remain in the chemical engineering branch, you will come across different kind of cases which can be explained using the kinetics. So please keep in mind that whenever you are looking for the mechanism, kinetics can play a major role. Okay. Any questions?
Sir, कोई भी डाउट पूछ सकते हैं.
कोई question है? Because today is the last lecture, so I will send few tutorial, and one day we may I can fix a time when, if you want, we can have a discussion regarding all those tutorials which I have sent. I am going to send you based on this all catalysis thing. But please keep that thing in mind, that kinetics is quite essential to know the mechanism. And I have discussed enough cases, and which should be enough for you to understand why kinetics is important. Any questions?
Sir,
Yeah, Sarthak.
लेकिन द फर्स्ट प्रेजेंटेशन जो अभी आप दिखा रहे थे इसके पहले वाला उसका स्लाइड मतलब बेसिकली मुझे प्रीक्यूलियम कॉन्सेप्ट वाला पार्ट थोड़ा समझ नहीं है कि क्यों यूज कर रहे हो लाइक प्रीक्यूलियम कॉन्सेप्ट मुझे तो पता है कि लाइक फर्स्ट रिएक्शन फास्ट है सेकंड स्लो होता है रिलेटिवली इसीलिए हम अज्यूम कर रहे होते हैं कि जो इंटरमीडिएट है उसकी कंसंट्रेशन काफी कम है और
That is for steady state.
एग्जैक्ट
Please keep thing in mind. Steady state is different than pre-equilibrium. Pre-equilibrium is again a specialized case of steady state. दोनों में कंफ्यूज नहीं करो. स्टडी स्टेट में इंटरमीडिएट हम देखते हैं. Certainly since our this thing is pre-equilibrium concept is a specialized form of steady state. Then you can say that intermediate is in low concentration. But apart from intermediate in low concentration, K2 value also is important. So K2, if K2 is quite small in comparison to K minus 1, then you can apply steady, pre-equilibrium.
So but उसका यूज हम लोग जो भी रिएक्शन है हम लोग प्रीक्यूलियम यूज क्यों कर रहे हैं?
Pre-equilibrium because most of the adsorption thing is reversible. Okay.
So because it's reversible, we use pre-equilibrium. I thought like pre-equilibrium use करें so that the equation becomes simpler to manage.
Equation becomes equal to?
Equation becomes simpler to manage. मतलब कि जैसे कोई terms.
No, that happens. It is always fast equilibrium followed by.
Okay.
Yeah. So it is not that we are using just because we want to make things simple. It can be applied because first step is always fast. Okay. Equilibrium step, you can think of that. Kinetics of adsorption and desorption is very fast compared to rate of reaction. Okay, too well.
Okay.
Okay.
Because like last time also in the class I was trying to ask you same thing, but like what I was asking was, is there any equation which is making it simpler? So I asked you that thing, but then.
No. It is simply we can apply pre-equilibrium concept because first step is very fast. In fact, if you go into more detail, it is like this deabsorption step is quite faster than rate of reaction. The second step.
Okay.
Okay.
Yes.
Any other question? So I hope that now you will be able to apply kinetics to get the mechanism. Purvi, what do you think?
Yes, so I think we can do that.
Okay, good. Utkars?
Yes, sir.
Okay. So please feel free if you have a question. If you are inside the campus, you can always come to me and discuss things. But first get the time and then you come. Yes. And all the best for your future. Okay. So if you have no question, I will leave.
Thank you, sir.
Thank you.
Thank you, sir.
Okay.
Thank you.
Thank you, sir.